All right, my name is Matthew. I'm a senior accounting major here at UTSA. I just wanted to get as involved as I can. So I joined the Investment Society to kind of teach over this fact exam review and try to help others learn. So basically, we're going to be going over a couple of the problems from the sample fact exam. We do need this. Y'all need to pass this fact exam as finance majors to be able to continue your majors. This is a very important test. So we can go ahead and get started in number one. We're going to be kind of looking at the present value and time value of money. This is kind of what we're dealing with, time value of money. So let's go ahead and get started. Number one, I like to kind of set it up just beforehand so I know what I'm working with, my numbers and my variables. So number one is asking for what is the present value of $100,000 received 5 years from now, assuming the interest rate is 8% per year. So right off the bat, it is asking us for the present value. That's what we are looking for. So I'd like to go ahead and set this up. It's going to be question one. Excel. It's not sharing the Excel. There it is. All right, so here's just how I set it up so far. This is number one. So I set up the present value. Just going to set up all of our variables: present value, future value, our interest rate, and being the number of periods, years, or months if it asks for that. And we're going to have a payment option as well. We're not really going to deal with payment too much in these first type of questions though, but it's just good to see that. So right off the bat, so I don't think I can look back at the, so in the problem number one, it does tell us our present value is $100,000. So that's where I get my present value amount. No, it's asking us for the present value. Yeah, that's my bad. So that's where I already know what it's asking for right in the first beginning of the problem. What is the present value? So that's why I put the question mark on present value because that's what it's asking for. It says the future value is actually $100,000. So that's where I would put that in. It gives us the interest rate. It says the interest rate is 8%. And it says per year. So we just automatically assume that that is the annual interest rate. We're going to plug in 8% for our interest rate. And being the number of years, it's going to be 5 years. And then payment, like I said, we're not really dealing with payment, but it's just kind of good to visualize. We'll just put a 0 for now. So these are all of our variables. This is the numbers that we were given and everything that we need to kind of figure out the present value. So all we have to do from here is just type in the present value formula. Just going to be equals PV. And if you press the parentheses, it'll tell you how to plug it in. It'll give you that you want to put the rate in first. We have the rate, the interest rate is going to be 8%. So I can go ahead and plug that in. Press comma, and it's asking for the number of periods. It's going to be 5 years. It gives us that in the problem. And now it's asking for the payment. Like I said, we don't have the payment, but it's just good to visualize it. The future value, it gives us $100,000 as the future value. And type is, we don't really need to worry about type, at least right now. So you can either close parentheses or you can just press enter. And a lot of the times, I'm not necessarily sure why it will come out as negative, but a little trick that I learned is you can put a negative sign in front of either the future value. I think it's just future value, I believe. And it will return it back as positive. So that's the answer that we're looking for right there. That's the present value of $100,000.
I'm sharing, I'll share it. And, put this flip back and forth.
And so on the fact exam, are we gonna have Excel?
They say you do.
Because I know how to do like that step with the calculator. I have the calculator, but I'm just making sure we're gonna have Excel.
Yeah, and I think you should be able to do an Excel like you just did. I even think even mainly 100,000 divided by 1.8 5th. You should be able to do it that way as well. But you can use Excel and use the functions, and the advantage of that is the Excel functions. So you want to plug in.
I'm not sharing my screen. How do I get rid of it?
Yeah, just hit the share screen and think you can just hit the button, or no, actually. Hit your escape key and you'll see that stop sharing at the top.
Oh, yes, sir. Okay. So that was number one. Number one is B. So we're going to look at number two. Number two says, Aaron places $200 in a savings account that pays 7% interest, compounded monthly. Compounded monthly is very important for us to notice. How much will she have in the account in 3 years? All right, so if I go ahead and set up my variables just so I can see everything that is given. So set up the interest rate, the number of years, periods, and the payment, even though we don't have any right now, I have to visualize it. So it does give us our present value. It gives us a number of $200. That's how much we put in a savings account today. So our present value is going to be 200. We are looking for how much she will have in 3 years. That's going to be the future value amount. So that is what we are looking for. We're looking for the future value. Now the interest rate and the number of periods, this is a little different because it does tell us that the interest is compounded monthly. That's going to be different compared to when it's compounded annually. And the way that is that it says it is 7% interest, right? But we have to divide that interest rate by 12 months because it's going to be compounded monthly, not just yearly. So we have to spread that 7% over each month. So the way that we're going to do that is we're going to put the 7% in, but we're going to divide that by 12. And we can leave it like that so it'll be visualized. We're going to do the same thing for years. However, it's a little different. For the years, correct? It says that we're looking for how much the future value will be in 3 years. However, since the interest rate is compounded monthly, that means that we have to multiply the 3 years by 12 for 12 months. So it's going to be 3 times 12. And just to go ahead and kind of visualize that, it's going to be 36 months, just spread out. That's how much interest payments are going to be made over 36 months. 36 months. So we can go ahead and get these numbers just by putting an equal sign. And so this is going to be our interest rate each month. This is going to be how long it is. It's going to be 36 months. Our payment is still going to be 0. We're not dealing with payment right now. And we are looking for the future value. And so to get this, all we have to do is type in the future value formula. It already sets it up like this right here. We can see what we need to plug in. We have all of our variables right here. And so we can go ahead and just plug them in. We have the interest rate divided by 12, of course. We have the number of periods times 12 to get 36 months. We have our payment, it's still going to be 0. We have our present value, that's how much she put into the savings today. And the type is still, we're just not dealing with it right now. So it is going to return us a negative number. And a little trick that I learned, of course, is just to put a negative sign in front of the either present value or future value. And it will return a positive number. Yes, that is D. All right, we're going to be looking at number 3 now. This one is dealing with rate of return. It's a little different than present value and future value. However, we still are using the same variables or numbers. So number 3, it says your grandmother bought a house 40 years ago for $20,000. So she bought that house 40 years ago for $20,000. That's going to be our present value amount because that's at the time, that's how much money she spent, $20,000. That's present value. It says today she sold the house for $92,000. Today would be our future value amount. What was your grandmother's rate of return annual on this investment? So we are looking for the interest rate here in this problem. All right, so if we go ahead and just do the same thing, set up all of our variables that we know, present value, future value. Our interest rate is actually what we are looking for. So I'll go ahead and put a question mark there. our payment. We're still not messing with payment too much, but later on we will. So our present value is going to be 20,000. That's how much our grandmother put down 40 years ago. So that's going to be 20,000 for the present value amount. And we'll go ahead and plug in our number of years. She did put in 20,000 40 years ago. And so the amount from present value to future value is going to be 40 years. It also gives us our future value amount. It says that today she sold the house for $92,000. That is going to be the future value amount, being that today she sold it. In the past, she paid 20,000. So this is everything we need to go ahead and calculate our interest, our rate of return. So all we have to do is plug in the return on interest formula. It's going to be RRI. Just plug in parentheses, and it'll go ahead and tell you everything you need to plug in. This is all the variables that we have. It asks us for the number of years, number of periods. That's going to be 40 years. It asks us for the present value amount. We have that as 20,000. It also asks us for the future value amount. We have that as 92,000. Go ahead and just press enter. And I like to kind of clean it up. Put it as a percentage because we are looking for the interest, and can put a couple of decimals. So it's going to be 3.89 rate of return on the interest.
Now you might keep a list of what you need. So you've done PV, FV, and RRI. So maybe just because you just gotta know what to plug in. The RRI is probably the most different on the calculator.
Mhm.
I think on the calculator, it's a rate.
No, the interest per year.
Is it the same?
Yeah,
Oh,
'cause I have the financial calculator, so it's just like
Yeah,
plugging in this and here and gets the same.
So I've never used the financial calculator.
There's a few extra steps you gotta do. That's what all the idea is.
For
You have
example,
to hit the command or enter.
yeah, what really messes you up is you don't
So
see
see the compounded monthly
Yeah.
too.
so it's just like
You get the compounded monthly.
20,000.
Yeah.
Yeah.
Negative.
This is like a refresher kind of thing.
All
good for the summer. I
Future
forgot what my
value,
professor was.
40.
I think she's a student.
Yeah,
Yeah, because look at this class she got. I believe it comes out.
just
to-
I always just
get
forget
it confused.
I don't know if they get
Like
like.
once you fill this out, you just put
Moved
computer
on to
interest.
students in the summer.
Yeah, I always forget.
Maybe
to
they work.
hit the
Yeah, that'd be pretty cool.
Yeah.
I learned it from like my
I do it by
accounting
hand,
courses. We
so I
have to
don't-
do
I don't
this
use
type of stuff,
Excel
but on
for
our,
that.
we have to use the charts. Like,
I
we have to
do-
find the interest
I
rate.
do 92 divided by
Just kind of like a refresher.
92 divided by 20 to the 140th minus 1.
But we also didn't get to use Excel. We all get to use Excel.
That's what I thought that was
Okay.
like for sure, like it is.
Because that's
We all
what
get to
we're
use
actually
Excel. So as
doing.
long as you just know the formulas, you know,
Yeah.
for you to look for interest to put in RRI, and it'll tell you what you need to put
Plus.
in.
Yeah.
So
93 divided by
Yeah.
20.
It's exactly like the. That's the same format. It's-
I would say it's the same format. It might be spread out though. These are kind of like the easier questions.
Yeah,
first.
I say.
The same.
But there's another one that he sent me where it's like very
That's probably
spread
just
out.
because-
There's any ones I have to learn.
You know,
I
study
don't
myself.
want, I don't want to be a black box. Exactly.
Yeah, it's like, I mean, I didn't know that one, but I did know like, the present value formula for that. I was like,
We can do 4 and 5 and then
Okay,
I think that'll be good for me.
yeah, because once you switch it on start, I'll use talking either. No, good, no.
Say it again?
Yeah, I don't know when there's like an obvious break for a new topic, but yeah, wherever you feel like you want to stop.
I think 4 and 5 are similar though to the rest, and then the 6 and 7, that's whenever it gets a little like different. So let's go through 4. All right, so it says Kenneth has $10,000 he is placing in a savings account. So that's going to be our present value right off the bat. He's placing that $10,000 today. The account pays 6% interest. That's going to be our interest, compounded annually. Whenever it does say compounded annually, it's kind of irrelevant. We automatically assume that the 6% is compounded annually unless it tells us otherwise. So it's good to visualize. If Kenneth makes no additional deposits and no withdrawals, all that's telling us is there's not going to be any payments. He's not pulling any money out, so our payment amount is still going to be zero. How long would it take to grow the account to $25,000? That's going to be our future value amount. So let's go ahead and plug these numbers in. We have present value, future value, our interest rate, number of years, and our payment. Right. So it says Kenneth has $10,000 he is placing in a savings account. So that is going to be our present value. He's placing that $10,000 today. Small one. That savings account is going to pay 6% interest compounded annually. It's just yearly, so it is going to be the whole 6% interest. We'll plug that 6% into our interest. If Kenneth makes no additional deposits and no withdrawals, means that he's not going to make any payments, meaning our payment is still going to remain at zero. How long would it take to grow the account to $25,000? $25,000 is going to be our future value amount. And it is asking us in the problem, how long will it take to grow the $10,000 to $25,000? So we are looking for the number of years that will take. Go ahead and put our question mark. That's what the question is asking. And all we're going to do is type in the number of periods formula. So it's going to be in parentheses, and it's going to be the exact same way. It'll tell us everything that we need to plug in. We have our rate already. It's going to be the 6% interest rate. Our payment is still going to be zero. It says that he didn't make any payments. He's not taking any money out, so it is zero. Our present value, he put 10,000 in today. He wants to know how long it'll take to get to 25,000. The type we're still not touching. So if I go ahead and just put that in, it will come up with the number error, and I've noticed that is because we actually have to put the negative sign here. If we don't, then it will give you an error message. So I'm just putting the negative sign. Either I like to put it over future value. I think present value and future value are interchangeable, but I like to do it over future value.
What they're assuming is when you make the $10,000 investment, it's a cash outflow, so that's negative. And then when it matures, 25, that's a cash inflow.
Oh, okay.
But either would work. I think of it as a negative 10,000 because I'm investing, and then it's positive 25 when it matures. But either works.
That makes sense.
You can do it as debt or do it as an investment.
So we'll do it under future value just to make it real simple. And that's going to be the number of years. You can, of course, clean it up to make it less. And to make it about 15.73 years is how long it'll take to turn the 10,000 to 25,000.
Is that it?
Yes, that's it.
Okay. Fine.
And it's D, yes. It says, Sam just took out a $15,000 4-year loan to buy a new car. If the interest rate on the loan is 8% APR compounded monthly, that's very important for us to notice again, compounded monthly. What will Sam's monthly car payments be? So here it's actually asking us for the payment. We need to find the payment. So we're going to use the payment formula, but let's go ahead and plug our numbers in. All right. So we'll go ahead and set it up the same way. Present value, future value, interest. It did say it was compounded monthly, so we need to keep that in mind when we're calculating the interest and the periods. And then payment is what we are looking for. All right, so in the problem, it says, Sam just took out a $15,000 4-year loan to buy a new car. So the present value is going to be 15,000. That's how much he is taking out today. He's taking out $15,000 on a loan. It does say it's a 4-year loan. We have to keep in mind that it is compounded monthly, however, the interest rate. So if we go ahead and calculate the interest, it says our interest rate is 8%. So we'll plug in the 8%. And it is compounded monthly. So we need to divide our interest rate by 12 because there's 12 months in a year. It's spread out over 12 months, our interest. And it says it is a 4-year loan to buy the new car. We have to go ahead and multiply that 4 by 12 because it's going to be, our interest is compounded monthly. So we need our number of years to reflect that. So if we go ahead and times 4 by 12, it'll return us a number of 48. It'll be 48 months. We can go ahead and just plug that in. It'll be 48 months. 2. This is our interest rate for each month for 48 months. Our future value, I actually do not think we are provided a future value. And I think for the payment, you actually do not need future value. We can go ahead and just put a 0 there. Yes, sir. It is 0 whenever you pay off the loan. That's correct. So we are looking for payment here. We can go ahead and just type in our formula, our equation. It's going to be payment. And it'll tell us everything that we need to provide. All of our variables are right here. We can just plug them in. It asks us for the rate. The rate is this number, and we did divide it by 12 to reflect the compounded monthly change. The number of periods is going to be 48 months. That was multiplied by 12. Present value is $15,000. That's how much the loan is today. Our future value is 0 because whenever we pay off the loan, we won't have anything else to pay. It will be 0. And the type is still, we're just not messing with it right now. So we go and press enter. And it will return that negative. We can go ahead and put it on the present value amount. Let's see. And it will return it as positive.
You executed something.
I did, right? Let's restart.
Controls, controls you had it.
Yeah, I don't know where I messed up. Let's just do the formula again for payment. The interest, number of periods, 48 months. We'll go ahead and put that negative right after this present value. Ask us for the future value, which is 0. And that should be it. His payments will be $366, which is going to be A.
I said APR, I didn't say APY, where I think it's confusing. Because APY, you'd have to do a lot of extra work. Because that would be the compounded rate. So you'd have to back into what it is. I don't think they asked that question. If they give you the APY, you can't divide by 12, you'd have to take, you'd have to do quite a bit of extra work.
I know it gets a lot more complicated. I used to struggle with that a little bit, the higher end.
Okay. So the questions coming up next. Another present value. So you got a lot of present values, so you can see that's where you're going to be better. So I'd encourage you, just like Matthew's showing you how to use Excel, but I also think if you can do it by hand without any formulas as well is really good. Some of these you can't really do it. You really have to have the formula to do it. But yeah, they say you can use Excel. So if they give you an exam and they'll give you Excel, tell them Dr. Baynot said you can use Excel. So he assured me. Have any of y'all tried the exam yet?
Not yet.
Yes.
So
If I were you, if you have the exam, when you schedule, just double check with Becky or whoever's setting up and say, I understand that you can go, to make sure so you don't show up there and suddenly there's no access. So Excel is a huge advantage because it does give you all those clues.
Makes it a lot easier.
Yeah. Good.
I think that's all I want to cover. I need to study like 6 through 12 and onwards. All right, this is Matthew Guerra, a member of the Investment Society. Today we're going to continue with the fact exam review. We're going to be looking at questions 6 through 10 and working them out through Excel and explaining the process. So let's start with number 6. It says Rachel is due to receive 2 payments from an insurance company. She will get $1,000 exactly 1 year from today and $2,000 2 years from today. Instead of the 2 payments, the insurance company is willing to settle the account by making one lump sum payment to Rachel today. So they're going to include both of the payments in one payment today. The insurance company applies a 6% discount rate for the 1 year cash flow and an 8% discount rate for the 2 year cash flow. What dollar amount will Rachel receive today? So I'd like to go ahead and look at the question that's asking of us. It's asking what will the dollar amount be today, which is going to be the present value. We're looking for the present value already. So I'd like to put the variables down into Excel that we know. It says that she's going to receive 2 payments, one of $1,000 and one of $2,000. So I'll go ahead and put my information that I know. Payment number 1, payment number 2. Payment number 1 is going to be $1,000 1 year from today. That 1 year from today is actually going to be the end for this payment. That's whenever she would receive this $1,000. So I'll go ahead and include that. Payment number 1 is $1,000. I put category for N. It's going to be 1 year from today. Payment number 2. Payment number 2 would be $2,000 2 years from today. So payment number 2 would be $2,000, and then the N is going to be 2 that we would use. Hold on. I messed up.
You can put an N over on the other side if you wanted to.
I was trying to do the undo function, but I didn't see it. I'll do it like this. All right, so this is going to be N, number of the 1 year that she would receive the $1,000 payment. This is N, 2 years that she would have received the $2,000 payment. That's all it says. All right, this is what we were given in the problem. It does give us our discount rates. It says that there's going to be a 6% discount rate for the 1 year cash flow. The 1 year cash flow is the $1,000. We'll go ahead and put that 6% related to the 1 year cash flow. I'll put it right here as the interest payment, 6%. And then for the payment number 2, is given as well. It says there will be an 8% discount rate for the 2 year cash flow. It's going to be the $2,000. 8%. This is everything we were given in the problem, our rate, our number of years, and the payment amounts. We do need to find the present value, but in order to find the present value, we need to figure out our present value factors of each payment so that we can calculate the present value for each payment. Once we have the present value for each payment, then we'll just combine them. So let's go ahead and use the present value factor formula. This is the formula. Oh, I'm just gonna put it so they'll see it. Plus the rate, and it's gonna be the power of the number of years. So that'll be just so we can visually see it. So if I go ahead and plug each of these payments into this formula, it'll give me the present value factor for that corresponding payment. So if we go ahead and do number 1. Number 1, when we plug it in, Plus, we have the rate. It's going to be 6% for this first payment. Plug that in. Those parentheses, the power of N, which is we would have received the $1,000 in 1 year. So this will be our present value factor number. You can kind of clean it up a little bit to make it easier to look at. And then we'll just have to do it for payment number 2 as well. So we follow the same formula. 1 divided by 1 plus the rate. We have the rate from the second payment. We'll go ahead and plug that in and take this to the power of the amount of years. It would have taken 2 years to receive this $2,000 payment. This would be our present value factor for payment number 2. So from here, to actually find the present value of each of the payments, all we have to do is multiply payment number 1 by its corresponding payment factor, and then payment number 2, $2,000 by the 0.86, the payment factor. So let's go ahead and work this out. We'll take the $1,000 from the payment 1, multiply it by the corresponding present value factor, and that will give us $943 present value of number 1, and we'll do the same thing for number 2. Ready? So these are the present values of both of these payments. If they were to basically be given to us over the actual periods that they would have, but instead we're doing the one lump sum payment. So all we need to do is take the sum of both of these numbers to find the actual present value of both of them combined that we will receive today. So we just take the sum. The payment that we will receive today will be $26.5807, $2,600. If we go back, that's going to be number D. Sorry guys, I was a little nervous. I had to like restart. Did that make sense, or there's a lot? Make sense? Yeah, cool. All right, number 7. This one's just kind of a definition-based type of question. It says, as the discount rate increases without limit, present value of a future cash flow, and how will it be affected? So as the discount rate increases, it's just going to decrease the present value of the future cash flow. Basically, an example would be like if the discount rate was 100%, the present value would be just about 0, if not close to 0. So the higher the discount rate is, the present value will just go lower. So it will approach 0, which is the correct answer.
And then if they say the discount rate declines without limit, then what does it do?
If it declines without limit, the present value will increase
To infinity again. Yeah. Remains unchanged and approach negative infinity. I don't know what negative infinity means.
I think it just means like it goes into the negative. So
It keeps going negative. Yeah. So there's present values. I guess it could be negative. You're talking about a future negative cash flow. Yeah. I don't know if they get that tricky.
see, but they like close it off like it can't go past 0 for some reason, even though it says without limit.
Now they might ask the question, as the discount rate increases without limit, the future value, what happens to the future value if you increase the discount?
Does it increase?
Yeah, that approaches infinity. And then the future value, if the discount rate declines, it doesn't approach 0. Because once you hit 0, the future value is just the sum of the cash flow. It's just the cash flow, right? You get $1,000 a year from now, and your discount rate's 0. No, I'm thinking backwards, right? If your discount rate's 1,000%, then yeah, it is pretty much worth 0.
Should be
No,
0.
we're talking future value. So yeah, future value. If your investment is 0%, then your future value is of $250, it's gonna be $250. I would know both sides, don't assume the question they're asking is the only thing they ask. Try to think higher, lower, present value, future value, be able to maybe do a quadrant, so
So if the discount rate increases, present value will decrease, of course, to 0. But if the discount rate decreases, or if the discount rate increases, the future value will decrease. That's like both sides of it.
if it increases.
The discount rate increases, the future value will increase.
Increase a bunch,
I'm sorry.
Yeah, present value goes down with higher rates. I don't think they'll say if the discount rate decreases without limit, because that could imply it could go negative.
Yeah.
I don't think they would say that. Decreases down to 0, what would happen? All right, but yes, make sure you're comfortable, because I don't know how many versions of the exam they have.
Yeah, that was a lot.
They tend to ask the same types of questions, but they might change the wording a little bit.
All right, so number 8, dealing with perpetuities. It says perpetuity will pay $1,000 per year, starting 5 years after the perpetuity is purchased. What is the present value of this perpetuity on the date that it is purchased? All right, so number 8, a perpetuity will pay $1,000 per year, starting 5 years after the perpetuity is purchased. What is the present value of this perpetuity on the date that it is purchased, given that the interest rate is 4%? So it doesn't necessarily mention when, if it'll be beginning or ending of year. So I would have to try both to go ahead and see which one is correct. It could either be for 5 years after the perpetuity is purchased, or for 4 years because the payments won't start until 5 years. So if I go ahead and just try to jot down everything that I have, I don't like. This is the one that will give me problems.
Yes, I would start with value the perpetuity first, because that's the easier one, just 1,000 divided by 4%. So
But I can't necessarily, I understand how to do that, but I didn't understand how to explain the 1,000 divided by the 4%. Because I know that's what gives you future value.
Well, you can actually test it. So let me show you, you might try it. So let's say someone using $1,000 for, I don't know, a few thousand years. You got 4%. You got year 1. And you can actually do the math. 1,000 divided by 1 plus 4%. Rates of the first. You just keep discounting them all. And you take the sum of that. You can get a really round number. Why do you get a really round number? That's just $1,000 divided by 0.04. So it works, right?
Yeah, it does.
So, but that formula is a lot easier than that.
Yeah.
So that's just the definition of perpetuity. Now, if this grows at 2% or 1%, then you don't have to take 1,000 divided by 4%. You divide by 3. Why am I using 3%?
You said it grows by 1%?
Grows by 1%. So perpetuity, when it grows at constant rate, you do the discount rate minus the growth rate. So there you can see it works.
Mhm.
If I grade at 3%, what would I divide by? By 1%. Yeah. See how it's now. If you're asking how does it work, we'd have to sit down and we could probably I can back into the present value interest factor annuity problem. I'm not sure I can prove to you why that's the right formula, but it clearly works, right?
Yeah, it does. I can see it
Clearly
visually.
works. I think you just have to say this is the formula for perpetuity. So you have two. You have a perpetuity. And you have a growth perpetuity. I can't spell perpetuity. Whatever it is. So this one is cash flow divided by I. This one's cash flow divided by I minus G. Those are the formulas. You'll see this formula, the second one, when you value stocks, so because that's what the dividend discount model is, right? But so you have to know both of those formulas, but yeah, this is the dividend discount model, and that's just, so that's what they're looking for. So I would start with that.
The 1,000 divided by 4% is actually the amount of the perpetuity, not the future value then, correct?
It's the actual present value, but you're gonna get it in the future. So perpetuities, this is a present value. And infinite cash flow. So it is a present value. What's confusing is it doesn't start into the future, but in the future, it's in 5 years, it's going to be worth the present value. Then you got to take that present value and take it back to this present value. So you have a present value in 5 years that you're going to try to figure out at time 0. So I would start with what's the value of the perpetuity?
Okay, we do that. Yeah, I was thinking like really in depth, not using just like the formula.
Yeah, I have to wording.
You know what I mean?
I don't know how to prove that. You know, I'm not being proof. I can do the present value interest factor one, but I can't do.
No, it's okay. That's I got it. So we'll go ahead and start off with calculating the perpetuity. We'll do $1,000 divided by the 4% interest rate. So we'll plug that in. Of the 4% interest rate. That's going to give us $25,000. We can use that as our future value amount just to plug into the present value formula, because that's what we're looking for. We're looking for the present value of this perpetuity. Since we did 4% interest rate, we'll use that 4% interest rate, which is given to us. That's going to be our interest rate. And our N is actually going to be 4 instead of 5 because it doesn't start paying until 5 years, but we have to take into consideration those other 4 years.
Yeah, where they're real confusing on this one is they don't tell you if it starts at the beginning of year 5 or end of year 5. So the beginning of year 5 is in 4 years. End of year 5 is in 5 years.
Doesn't clarify.
Said to assume ending. So
Assume ending.
Yeah, but that's what we did, and you don't get the right answer, you know. So what he did is try it both ways. They shouldn't write a confusing question at the beginning of it, right? But they did, so you don't really know.
So we can assume ending or beginning. Ending would be 5 years. We can try it both ways. Like, yeah, I can understand that. We can try it both ways because it doesn't clarify if it's we assume ending or beginning. We'll try 4 will be the beginning.
Yeah, very easy. And you make the most sense.
5 would be the ending. And so, all right, let's go ahead and plug this into our present value formula. Try it both ways and see which one is the correct answer. So the rate, we're given 4%. We'll try number 4 first for beginning. Payment's going to be 0. Future
I
value.
don't think you get 0.
Oh, I'm sorry. I put O.
You're over there.
And future value would be $25,000. So that returns the 21,370
4 years, yeah.
with 4 years. And I do believe that is the correct answer, but we'll go ahead and look at 5 years as well, just to see what it'll give us. We'll plug that into present value. Rate 4%. Plug 5 in for assuming that it's at ending. 0, future value is 25,000. It gives us 20,000, which is not an answer choice, but it is close. But this one is legitimately number C, which is the correct answer. So we would assume that it'd be at beginning, but it does not clarify it. Yeah, that was like, this one gave me a lot of problems compared to the other ones.
Yeah, that's starting 5 years after it's purchased. That sure sounds like in the 5 remain. Yeah, it's pretty. If it said starting in year 5, because year 2 is 1 year from now. But yeah,
Number 9, your friend Barbara has a bond that she would like to sell to you. The bond matures in 10 years, has a face value of $1,000 and a coupon interest rate of 6%. If you know that the yield to maturity on similar bonds is 8%, what is the maximum price you would be willing to pay for the bond? So here's this problem. Barbara is selling us a bond. It does tell us that the face value is $1,000, but the bond actually has a coupon interest rate of 6%. We need to take that bond and multiply it by its coupon interest rate to calculate the amount of payment that'll be made. So let's go ahead and this is going to be the payment. Sorry. So we take the $1,000 face value, multiply it by its coupon interest rate. 1,000 multiplied by the 6%. And that's going to be $60 payment. It does tell us in the problem that the bond will mature in 10 years. That's going to be our N, 10 years. If we know that the yield to maturity on similar bonds is 8%, we're going to be using this 8% as our interest rate. That's going to be the similar yield to maturity, which is what we're going to want to use. The bond does have a face value of $1,000, which means that the future value is going to be $1,000. And we're actually looking for a present value because we want to know how much we're going to be willing to pay for the bond. Put that in. So once again, we just have to plug in these numbers into our present value formula. And it will return us the amount that we would be able to pay for this bond. So we plug these in, we have the rate, 8%. The number is going to be the 10 years. Payment is the 60 that we calculated from the 1,000 times its coupon interest rate. And
Minus the future value probably.
then yes, we'll do that. We'll do the future value of $1,000. We go ahead and include that minus. That will return us. Percent, what you pay for the bond.
We take the minus out, maybe I messed that up. I don't think so. Seems right. You can use a negative number.
Supposed to put it on present. Yes, you're supposed to put the negative on present value.
Okay.
So that'd be the 865, which is number A, and that negative explained is just for the present value. That's how much we would be willing to pay for the bonds. So we would be giving that money away.
Yeah, my class don't do that. Bonds don't pay annually, they pay every 6 months. So what would be the answer to every 6 months? They may not ask that, but yeah, this would be 30, this would be 20, that would be 4%. So it's gonna be a little bit higher, but yeah. But we won't do it like this in class. We're gonna use the actual formula. So I'm real picky in class. So
That question I will ask that.
I don't think I've not seen them do anything but annual coupons, but in reality, bonds don't pay. You know, treasuries are semi-annually, all corporates are semi-annually. Yeah. It's just that's just the way the bond market is for some reason. So why they give you all annual bonds, I think just keep it simple.
Number 10, coupon bond, which pays interest of $60 annually, has a par value of $1,000 and matures in 5 years and is selling today for $915.48. The yield to maturity on this bond is approximately. We go ahead and look at our numbers that we're given in this problem. We don't want to get this first part confused. It says that the coupon bond pays interest of $60 annually. That's not going to be tied into interest. That's actually going to be tied into payment because it says that the coupon bond pays interest. So we can just say the coupon bond pays $60. That's our payment. Our payment number is going to be $60. Has a par value of $1,000. That's going to be our future value. $1,000 is what the bond is worth. Matures in 5 years. That's going to be our N. And it is selling today for $915.48. The key part is that it's selling today, which is our present value today. We'll plug it into our present value. This can be 915. 48. Now we're actually looking for the yield to maturity on this bond. The yield to maturity formula is just taking the rate. So we're going to go ahead and plug this into equals rate. And that's going to return us the yield to maturity on this bond. So if we go ahead and plug all of our numbers that we have the number of the payment, which is 60. It says in the problem. We have our present value, 915.48. That's how much we're selling the bond for today. And our future value will be $1,000. It's the par value of the bond. Present value.
Did it.
Sorry about that. And then
That's what you always put that as negative because you're assuming, okay, yeah, that makes sense. That's the
Yeah,
logic. You're
makes-
buying it.
makes more sense to me. The present value would be negative instead of the future values.
Yeah, because you're paying for the bond. Yeah.
As we're paying for it. 915 is selling today, so that's how much we would pay for it. I'll go ahead and those are all the numbers that we have. Enter them all into
Now,
the
before you hit center, let's think about it.
Okay.
What's the coupon on this bond? 6%, and it's going from 915. If the yield, the maturity was 6%, you'd pay $1,000. So the present value goes down when interest rates go up, so you know it's going to be higher or less than 6. Higher, and they don't give you anything below. But if you saw 5%, you know that's what. So this is a discount bond. So discount bond, the discount will always be higher than the coupon. How much more? This bond, I can tell you, its bond has a duration of about 5 years. So have y'all learned duration yet? We'll talk about it in our class. Do you know duration yet? So it has a duration of about 5 years, and its price fell about 8.5%. So the rate is probably up about 2%. I'm going to guess 8. We'll see. Hit enter and see how wrong I am.
No, you're actually right. Yeah, you're right.
Yeah, so there's a formula that's minus duration times the change in yield tells you how much the price has fallen. A 5-year bond has a duration of about 5 years. So minus 5 times 0.02 is about minus 10%, and it's down about 10%. If it had been 955 or so, that would have been the 7%. It had been 860, it would have been the 9%. But we're going to talk about that in our class. It's a real quick way that you can kind of double check it in your mind.
Alrighty, this is going to be a little review over the fact exam. My name is Matthew Gata. I'll be going through some questions here, break them down and read them. So we're going to start with number 11. It says dividends RS is paying a dividend of $3 a share today. It is expected that the company will continue its policy of increasing its dividend 8% a year. If you require a 14% rate of return to invest in this company, what is the maximum amount you'd be willing to pay for a share of stock? I like to go ahead and note down everything that I've been given in the problem. Makes it a lot easier to read, see, and plug into my actual formulas. So it says they're paying a dividend of $3 a share today. I'll note that dividend will be $3. It is expected that the company will continue its policy of increasing its dividend 8% a year every year. That's going to be the growth rate. That's how much the dividend is going to grow. Put that as growth rate 8%. It says if you require a 14% rate of return to invest in this company, that's going to be our rate of return right there. %. And this is everything we've been given. Now it's asking us what is the maximum amount we're going to pay for a share of stock. So I have the formula that we're going to use already, just kind of set out so we can see what I'm going to be plugging the numbers into. The D is the dividend that we are given. 1 is just a given in the equation. The growth rate what I have here is going to be the 8%. And we're going to divide that by our return rate minus our growth rate. That's going to return us how much we would pay for a share of the company's stock. Let's go ahead and plug this in. Take the dividend multiplied by 1 plus the growth rate. Divide that by the return rate minus the growth rate. It's going to return us a number of $54 per share, which is going to be D. D is the correct answer. Right, number 12, a firm is planning on paying its first dividend of $2 in 3 years. After that, dividends are expected to grow at 6% per year indefinitely. Stock's required return is 14%. What is the value of a share today? This one is similar to number 11, except we do have to find the terminal value and plug into a kind of similar equation to determine the value of the share today. Let's go ahead and get down everything that we know. It tells us we have a dividend of $2, 3 years. Dividend is going to be $2. Dividends are expected to grow at 6% per year. That's going to be our growth rate. %. And the stock's required return is 14%. That's going to be the return rate as well. %. We're looking for what is the value of a share today. We do have to find the terminal value, which is just essentially the value of the stock today, but we have to take into consideration that it's going to be growing forever, indefinitely. This is the formula to calculate the terminal value. We're going to plug in the numbers that we already know from our problem, and it will return us the terminal value. So go ahead and plug these in. We're going to take the dividend divided by the return rate minus the growth rate.
One thing to point out here, I don't know if y'all noticed, but in the previous formula, we did dividend times 1 plus the growth. But that's because that's the dividend they paid last year. We can't get that dividend. Right? Here, the dividend is in the future, so we will get that dividend. We only apply the growth rate to it. So what you use in the numerator is the next dividend. Their next dividend is $2. The previous question, their next dividend, last dividend time. Sometimes it's Matthew says dividend. I usually say either dividend 0, which means last dividend. I'm doing the next one, or dividend 1, which is the next dividend. Here, you're really doing dividend 3, I think. But it is the same formula as before. It's just that it's a future dividend instead of a past.
Makes sense, because then we have to reverse.
Yeah, I gotta bring it back to the day. Yeah.
So it did return us a value of 25 for our terminal value. Now that we have 25, plug that into our other formula for today's value. It's going to return us the answer value of shares today. We go ahead and plug this in. We have our terminal value divided by 1 plus return rate. And we're going to take it to, it's confusing. Yeah, so we have to calculate the share of today, and the way that the professor described it, we were trying to find dividend 3. Basically, this is what this is, D3. I just put it as regular dividend. So if we're trying to find it today, we would go ahead and take this to the second power to reverse it by 2 years, which would be today. Makes sense?
Well, it's either 2 or 3, but you can't tell from the problem. I read it when they say in 3 years. I don't know if they mean you're going to pay the dividend at the beginning of year 3 or the end of year 3. If you use 2, you're saying beginning of year 3. If you use 3, you mean at the end of the 3 years. We don't know which one it is, do we?
it says in 3 years. So I think when I did this problem, I did it raise to the second, raise to the third. Fortunately, both answers are in the entry key. So you just find the one that works. So try 2 and see if it's 2 in the entry key. 1924. That's right. Try it with a 3 and see what you get. That one, they're both in there. What do y'all think? Dividend in 3 years. That I would probably use 3, but yeah, I have to talk to the guy who wrote this. It's really confusing. In 3 years, it's very ambiguous. I would say at the end of 3 years, at the beginning of 3 years. So I would probably use 3, but they're both answers are in there, aren't they? So yeah, I have to ask. Yeah, that's really poorly written question. Does it? They show you the solution on that one?
Oh, yeah. It's 19.24.
N of 2. Yeah, they're saying it's N of 2, but I would disagree with that. I would protest.
It is very.
Both are right depending on what they mean by in 3 years, but
That would have been the C.
I'll try both, and if only one of them's there, then you got it. If they're both there, I don't know why you would raise that to the second, the way it's written. Very confusing.
That was the more confusing one.
And it's poorly written. So, yeah.
All right, number 13. XYZ Corp's common stock can be purchased today for $32.25. Is expected to pay $4.25 dividends next year. You can sell the stock for $38.50 right after receiving the dividend next year. What is the expected return if you purchase the stock today? All right. So I'm going to use the numbers that we were given, plug them in to this formula essentially, but I like to go ahead and break it down what we have. So we're given the common stock can be purchased today for $32.25. It's going to be our current price of the common stock. It is expected to pay $4.25 dividends next year. So that's going to be the dividends for next year. And we can sell the stock for $38.50 right after receiving the dividend next year. It's going to be the selling price for the stock. That's how much we can sell it for. Selling price for $38.50. This is everything we were given in our problem. We were asked, what is the expected return if you purchase the stock today? We're looking for the return rate. The return rate formula I have is right here. This is what we're going to plug into, so we can visually see it. It's going to be the return rate equals dividends plus our selling price, $38.50, divided by our current price minus 1. 1 is just a given in the formula. So I go ahead and plug this in. Dividends plus our selling price divided by our current price minus 1. Return, it was supposed to be a percentage. Yeah. 33% is going to be D. That's going to be our return rate for the stock. Purchase of the stock.
So for Colby and Marcus in my class, the formula I use is current price minus purchase price plus dividend divided by current price. But don't subtract 1. It's the same formula, but I confuse you. The same formula. But yeah, there's a couple different ways you can do that. Yeah, 33%. Sorry. You'll notice here they say dividends next year. that almost to me sounds like a 2. It's this year, end of this year be 1, end of next year be 2. So I think when they say next year, they mean this year is 0, next year is 1, 2 years from now is, I think, or 3 years from now. So 2 years is next year, which is 1, 3 years, it's 2 years from now, 2. That seems to be how they interpret it, but they should word it a little better. So next year to me could be 1 or 2, but you hear doesn't, you don't have enough information. All you can do is what you put in there.
I think it'll be worded like it's kind of poorly. They're actually testers.
I think they're the same question. They just changed the numbers. So I think you'll see a lot of different answers. I might email Dr. Baina and say, because it probably is the way a certain professor teaches it from a certain textbook. And that's just they way express, but I think you shouldn't do poorly in the fact because the wording's confusing. So this one's fairly straightforward because you really couldn't adjust for multiple years, even if you wanted to, but it's really tough. All right, good. Awesome. All right. XYZ Corp has the same amount of sales every day. 30% of its customers pay cash immediately upon purchase. 40% of the customers take discount, pay up on the 10th day after sale. The remaining 30% of the customers pay in exactly 40 days. Whereas the average days sales outstanding. Yeah. So we're gonna go ahead and get 2 columns here, or 2 categories. We're gonna take our days that each payment is made and our percentage, how much is given on them. All right, so we're giving 30% of its customers pay cash immediately on purchase. That means we don't have to wait 10 days, we don't have to wait 20, it's given to us immediately. 0 days. 40% of the customers take discount and pay up on the 10th day after sales. 10 days we have to wait to get that payment from 40% of customers. It does tell us that they take a discount, but we don't have to take that into consideration. We aren't given any number or any rate, nothing like that. The remaining 30% of the customers pay in exactly 40 days. So we're not going to receive their payments 8 days later. Where's the average day? So we have 30% pay immediately, 40% pay on the 10th day, and 30% pay in 40 days. So we need to go ahead and weigh each of these different categories to basically be able to sum it and take the average of it. So if we go ahead and just multiply these to weigh it out, times 0 days by 30%, it's going to return 0. We don't have to wait a single day to get that payment. It pays immediately. Take the 10 days times the 40%. That's going to equal 4 days. And we do the last one. Take 40 days, multiplied by 30%, return us 12. Then we just take the sum of these. That's going to be our average days we have to wait for the payments to come. Just 16 days. Which is E. Can I show you a formula? I don't know if y'all know this formula. I use it all the time. I don't know if you use the sum product function. All right, you want to do it with sum product because that's pretty cool. Equal sum product. Do your days and then do your percents. I like 3 days all the way over. A comma, percents. Yeah, enter. You should get 16. Yeah. Y'all use some product? I use it all the time. It's really powerful. Go to this kind of break it down. Just like, we have models that have like 50 factors, each have a weight. We can just do some product, do the weights times each factor all the way down for 100 companies. We could get it like that. It's really, I didn't know it existed. I used to do A times 1 times 2, all the way, and some product does it all for you. Good. Now, I want to know why the people paying immediately did just pay in 10 days and get the discount. Yeah, because that's their option. Yeah, that's smart. Good.
That was all I had for today.